Let's get started. So my talk, now that we have got to it, is titled Digital Empowerment Through Personal Agents. I am Oak. I'm one of the co-founders of Valory and a builder in the OLAS ecosystem. I have, over the past months and even over the past weeks for example, at the Augment Hackathon last week in Paris, seen lots and lots of interesting experiments being run into end user facing autonomous agent applications. Valory is obviously very interested in this space as well. But what I wanted to focus on today, rather than going into the details of those types of applications, was to step back, as we are so early in this journey, and focus on the context of why these applications matter. So starting here, I think that although the web is getting more and more powerful, as humans, we tend to get less and less out of it. The ad model which powers the web is very rarely aligned with our individual goals. Public discourse and culture is overrun by the financial, political, and social goals of corporations and governments. And an example that I see personally of this in my own experience online is that anytime I want to use, for example, Twitter to engage in public conversation, I feel constantly sucked into the drama that's being generated there, which is, of course, all motivated by the company's need to keep eyeballs on advertisements. Secondly, we are swamped by annoying and often scammy automated systems, where again, I feel like 1 in 5 notifications on Twitter are bots and often attempted scams. Thirdly, the sheer volume of options in terms of information which is available today is totally overwhelming. And similarly, there's a huge amount of functionality now available through the internet that as an individual, I feel I'm only able to make a tiny fraction of the use for. With the advent of powerful AI models, I don't see how this is going to get any better. Institutions will have more powerful means of keeping us in their orbits. Bots will become cleverer, scams will get worse, and information and services will become increasingly difficult to navigate and utilize to their fullest. So what's the ideal? I think it's often best to kind of step back and look at the most extreme solution to a situation in order to kind of plot a path forward. And so I think that ideal is really to try to reset the playing field and give individuals as much of the capabilities and capacity of the institutions and machines that are dominating the internet of today. So what does that mean? Firstly, I think it means that we as individuals need to own much more of the means of discovery of content and functionality that is built around our own interests rather than that of misaligned institutions. Secondly, I think we ourselves need to begin to participate a lot more in the machine economy, spreading access to individuals such that we can benefit from machines that can traverse the internet rather than having these solely in the hands of specialized developers. Thirdly, I think we need to increase our discovery capabilities, and that means vastly expanding the ability for individuals to reach into the depths of information that's available on the internet and adequately process it. And then finally, I think we need to expand the productive capacity of individuals such that we can make use of all of the functionality on the internet as well. These are lofty goals, and as I say, it's an sort of extreme kind of vision of what to aim for. But I also think that the path there is no longer entirely out of reach, given kind of recent advances in our technological capacity. So firstly, today we have been unlocked by open financial services and data via smart contract blockchains and other Web3 infrastructure. Secondly, LLMs have given machines a brain, enabling them to process information and take action autonomously. And thirdly, and finally, full autonomy will unlock machines to act fully independently under the ownership of individual humans, unlocking powerful new user experiences that are aligned with our personal goals. So there's, these tools have unlocked a path, but we obviously all still need to walk that path, and there's an enormous amount to do. And so we want to encourage everyone here to come together to push forward for these goals. For example, Web3 infra needs to be built out, LLMs need to be honed, and autonomous agent capabilities need to be refined. And in part, that is why we put on these events, is to foster that conversation. Specifically, though, we have 2 programs which we are running in order to push forward. And these are both things which folks in the audience here today might want to be involved with. So firstly, for people who are interested in experiencing the future of personal agents today, we have the Secret Agents program. And this allows select applicants to work directly with Valory to build personal agent systems around their unique goals. There's a QR code there for a sign-up link. You can also reach out to myself or Thomas afterwards if you would like that link and you don't manage to scan it in time. Secondly, we have a program which is available for people interested in running agents and developing upon them, which is the Agent Predictions Hackathon, which we're running with Gnosis on Gnosis Chain. So here you can run agents and refine their strategies in order to compete for essentially rewards, which are available through prediction markets which have been set up. And that's a total of $3,000, which will be available there. And there will also be prizes available from Valory and Gnosis for developers who build out useful and cool extensions to their system. And I'm particularly excited about the Agent Predictions Hackathon, because it's an extremely concrete application of AI in crypto, but specifically autonomous agents. So finally, just to kind of round this up and summarize it before I sign off, Web 2, I think, is undoubtedly quite overrun at this point by institutions and machines. And I think we need to find solutions because the situation will worsen. The goal to reach for is to empower individuals to become comparably capable to these massive players. And the tools are there to achieve this, but there's obviously a lot of work to do, and we'd love to work with all of you in order to achieve it. So thank you very much for your time. I think there was a bit of messing around on my end at the beginning, so I don't know exactly how much time we've got for questions, but if you do have any, then feel free to shoot them through.
Yeah, so thank you very much for that. Yeah, you do have about 2 minutes, so we can check the text chat for questions, and if we have written questions, I can read them out so that people watching the replay will get to hear the question and the answer. And then I will also say again that we do have an open QA session at the end. So because we're running a little shorter on the amount of time for questions, we will have the opportunity to put those questions towards the end. So do stick around for that. It'll be an open kind of Q&A dialogue. Okay, so Roberto Enriquez asks, what are some of the use cases of the Secret Agent program? I can show that.
What are some of the use cases of the Secret Agents program? So the Secret Agents program is the purpose of the Secret Agents program is basically to build autonomous agents around the personal goals of the people who get selected to be a part of the program. So Valory has carved out dedicated resources to essentially build around anybody who gets accepted onto the program's goals. So at this point, we won't say like what specifically it's focused on. We really want to build as much as possible around the kind of desires and goals of the people who apply.
Perfect. Yeah, thank you so much for inviting me. So my talk will be why I think that prediction markets could be the fabric for human AI collaboration. Little bit of a disclaimer, I am not working on this problem. My day job is I'm product manager at BrainBot for Shadow Network, which is a threshold encryption scheme for encrypted mempools against front running and censorship. So not really directly related. I mean, we've talked a little bit about there could actually be front running issues within this topic, but it's just a different problem. But yeah, I'm just personally excited about, and I have some stupid ideas. And some use cases. So that's what the talk is going to be about. Just trying to talk about these ideas and trying to get people more excited. Why do I think it's exciting? Because I think ultimately crypto can set AI free. So basically, crypto can be the world in which the autonomous AI lives in, basically. So contrary to the cool thing would be it wouldn't have to be owned by a human. It could actually own itself. I think that would be super interesting. And then it's basically something. Ultimately, it would be the closest thing I think we can do right now to create a real sort of synthetic life. So I mean that as a overarching thing. Why is this super exciting to me, and also maybe dangerous or yeah. I'm looking at this from two different sort of problem solution sets. So for the one way to look at it is there's this grand vision about prediction markets and futarchy, which I think is amazing, and I feel like if we can make this reality, it would be very exciting. And I think there's not enough time in this talk to talk about why, but yeah, it is a really cool vision. It was previously too expensive because you need humans to create and trade on these markets, and the UX just isn't that good of doing so, especially for like normal people. So and the one thesis or the solution would be simple, saying okay, AI can solve the problem of UX and solve the problem of trading, so that sort of AI is the enabler for prediction markets. The other way to think about it, I think, is also more interesting potentially, is the problem set. The problem is that human and AI can't really collaborate well right now. It's not really clear how they collaborate exactly, especially around incentives. So humans aren't incentivized to provide information, and vice versa. So I feel like then the solution is meshing markets with AI, right? You kind of creating this marketplace around providing information for AI or training. I think there's been lots of discussion around this as well. But then the problem with traditional markets is they're slow and static, and they provide only a certain type of information to the AI. So that's why I'm thinking prediction markets are interesting, because they're the opposite. They're less static. They can be very specific. They can provide very specific, interesting information. Yeah. So then the overarching solution is meshing prediction markets with AI. That's sort of the overarching topic of it for it. And then I just created some stupid examples or ideas, right? How this could look like. One is the AI prediction market strategic advisor. So think about your ChatGPT. You could ask it. In this case, it's you are the owner of a mid-sized coffee shop chain, and you're asking it whether to expand into online or physical stores. And let's say the AI doesn't really have enough information to do this, maybe because it's too specific or because it's too recent. Or so then the interesting thing would be you type in real time, sort of it pops up these these real time prediction markets on three different kind of data points that it needs to gather within seconds. So I purposely put this here in only very small intervals, seconds intervals, basically, where the other AIs or humans then start trading on these data points, and then that immediately gives the ChatGPT the input that it then needs to generate a solution as a recommendation for this. So I find this super exciting, this idea of just typing in, and in real time it creates these markets. Yeah, and I think something that could be built probably with your guys' tool set, the Valory, and yeah. The other one, something that just a small idea, or just a small kind of part of it, where what if there was an AI investment assistant which asks you, kind of interviews you about your all your preferences, your views about the world, and then creates a portfolio from that. And then I feel like this could already be done with stocks and derivatives to a large degree, but maybe like to 80%, right? But then you might have very specific ideas, or you might have things that you cannot replicate with the traditional markets. And then I feel like it would be super interesting from there then to create the remaining sort of exposure, create the remaining investment vision, create that again with prediction markets, and then all together represents your worldview in the financial sense, and then represents basically that's your input to the economy, and that's how you can then earn money based on, hopefully you have some knowledge that others don't have, or you have and that would be, to me, kind of an ultimate way of kind of passive investment, right? And then the third one is kind of a stupid idea, but I thought also like an potentially interesting thing, where the goal here is to have an AI fashion design process. So you could have someone sets the goal of saying, I want to sell a certain dress, and I want to generate max income for this dress next year. And then we could have an LLM create sort of design concept, but also uses generative AI to create the designs, and then opens prediction markets for this. So this could look like this, right? You just creates lots of markets in parallel, and people start trading on this, and so the price would be how much can it generate if it was actually made into a real dress, and then this could basically determine what should be the design, right? And then I feel like it would be even more interesting if you bring in this evolutionary or generational AI type of thinking, where you'd say, okay, maybe one of the markets is performing really well, and in that kind of latent image, or that idea could then be iterated upon, and be used as an input for another kind of generative AI process, which then opens another set of markets, and then again can trade on this. Yeah, and then basically it could be resolved first, just like a self-resolving prediction market, right? But if people want to, or if people actually want to resolve it, they could use Reality.eth or Kleros to actually say, okay, I'm going to actually invest the amount of money to actually make the dress into production and then sell it. Yeah, and here's there's just a stupid kind of way of showing it, in that the latent image of the one of the dresses can then be used here and made into another set of new. Yeah, so that's just how it would look like in this node, in Comfy UI and this Stable Diffusion thing. Yeah. But yeah, kind of that was it. And yeah, again, sort of, I'm just a fan. Follow me on Twitter if you want to read more about stupid ideas like this, or follow the Shutter Twitter if you want to learn more about MEV and front running protection, essentially.
Cool. Thanks a lot for that. That's really cool. It's really interesting to see, like, prediction markets. This is something we haven't talked about in these series before, but it's a really obvious fit for adding, like, to how can we make predictions where the predictions come from an artificial intelligence rather than a human intelligence? Because yeah, I think it's a really natural next evolution. So it's really cool to see that. We have a couple of questions which I'll read out. I don't know if you can see some of these. Sandeep has maybe not a question so much, but more of like a rhetorical kind of comment on. So you have this proof of concept with these like designs, and you have a very good UX. But Sandeep is asking, what's the good UX without market depth?
Yeah, true. But I mean, that's that is where the AI can come in, right? That is where where previously it would have been too expensive to let humans actually trade on these markets, and then the hope would be the AI plus humans, or basically humans controlling AI makes it much cheaper to create that market depth because the autonomous agents are actually trading.
Yeah, I think we saw something sort of similar to that with our ideas with the autonomous ecosystem about the way we could maybe validate the usefulness of bits of code by not like, obviously we can have humans voting for what's useful, but you can also, if you have these autonomous AI agents, they're always working, and they're more like agnostic if designed correctly. So that's really cool. So Oak has mentioned that last week you mentioned the idea of prediction markets as an intermediary between AI and humans, and he'd be interested if you could talk to that idea a little more.
Yeah, I mean, the examples that I showed, those I try to, that's basically the overarching topic, where I'm saying like that's the incentive layer between humans and AI, right? So for the simplest example would be this coffee shop example, right? Where the human creates, the AI creates a prediction market which incentivizes humans essentially to provide information to the AI, and then ultimately to the owner of the AI. But that's what I meant. That's one of the examples of there is kind of this intermediary or mesh between human and AI, and I feel like, so back then so one way to look at it would be it's an interface between human and AI, but I feel like that's not really the right word, because ultimately people don't even want to have the interface be a market, right? It's not really nice. Like, you don't want to trade, you want to sit there and trade all the time. So that's why I think the better way of putting it, it's this mesh between it, where the human uses an AI to interact with the market, and then that kind of processes information, and then another human also uses an AI and also interfaces via this market. So the market becomes the ultimate kind of connection point. But yeah.
Cool. So I have another question from Richard. I'll just throw this one up here. Richard says, oh, sorry, that's me. I missed. Richard says, have you thought about using prediction markets for creating an AI constitution or principles for a community-owned AI?
It's just super interesting, yeah. But I think I can't really speak to this, but sounds like a super interesting. So in that ethical topic, or I'm not really sure how exactly that's meant, but it sounds super interesting, yeah.
Here's another interesting comment from Evan Powell. For what it's worth, JokeDAO is getting increasingly used for collective sense making, similar to prediction market in a sense, where agents could contribute to that process.
Yeah, awesome, yeah.
Okay, cool. Yeah, so we've got about a minute left. So if there's so we already mentioned where viewers can connect with you. You are at Bezzenberger on Twitter, and Project Shutter is at project_Shutter. If people want to reach out to you about either what you presented or what Shutter is working on. Is there anything else you would want to add?
No, thank you so much for giving me the opportunity, and super excited for the tools and sort of frameworks that you guys are building that enable some of these ideas that I had. Yeah.
Yeah, awesome. Thank you for choosing to share, and also for bringing such an interesting and something that we haven't talked about yet. So that's really great to see. Cool. Thank you, Lee. So I'll take you down now, and we will transition over.
Hello, I'm Kelsie Nabben. I am a lead social scientist at Block Science, a complex systems engineering firm, as well as a PhD level researcher from RMIT University in Australia, conducting my postdoctorate with Blockchain Gov. I have a brief amount of time to share with you today on AI accountability in/and governance. And so what I'm really interested in here is, I guess, the rise of LLM GPT agents and how Web3 projects are incorporating those into governance, and what the considerations are when projects do this. And so I'm not necessarily recommending this, but more as soon as I played with ChatGPT myself, I knew that this is a very likely direction that projects would go, and many are. So here's a bit of a journey of sort of research and some design work so far, and you'll notice that it ends in kind of a call to action. I'm really interested in working with relevant projects on this research, as well as in the design space. And so here's a brief sweep of some of the projects, including Autonomous, thank you for hosting this, that are starting to think about how to use LLMs in governance and decision-making contexts within their projects or communities or protocols. So MakerDAO is talking in the endgame plan about using AI agents to interpret their very lengthy and comprehensive kind of constitutional documents that they're developing. Algovera is around personalized agents, but I don't want to do them a disservice because I know they're probably listening here based from Twitter. Token Engineering Commons approved funding within their community to use LLM agents in token engineering design, and that's really being taken as an experiment to see how that can be done and what the considerations are, as well as Ceramic, Ocean Protocol, and others. And if there are others that aren't listed, I'm really happy to hear from you and include you in this sort of lay of the land. So first of all, what is accountability and why are we talking about it? Well, when there's decisions made, we want to know who's made them, how they've been made, and also to make adjustments when required. And so I've provided kind of my definition at the top here, and I'm really focusing on sort of building on Boven's, which is sort of a broadly accepted academic definition around the relationship between an actor and a forum. And so you can think about an AI agent as an actor, and a forum might be the community that it's acting upon, say in governance decisions, like Autonomous, for example. And so algorithmic accountability is when an AI agent can be questioned about its behavior, and then there can be a verdict by the forum that conducts the questioning, which can result in consequences for poor behavior or behavior that's not in line with the objectives of that broader forum in which it acts. So it's both a process and an outcome. It's about the outcomes of the decisions that are made, but also the processes of how they are made and the ability to actually inquire of what those processes are. And so there's quite a few open questions that this raises when we're inserting, really expanding what we call the governance surface of, for example, feeding into snapshot votes. So how does one know where an AI is operating, or maybe the question is, how does someone know when a human is operating? Who controls it? Is it an individual? Is it an organization? Is it a broader community that's deploying agents on behalf of their interests and objectives? When is an AI agent an actor, and when could it be a forum as well? So what if you had forums of AI actors, and what if humans were the agents that were being held accountable to them? How can a forum question an AI? What are the consequences for bad behavior? So how do you enforce consequences on an AI if they have misbehaved? And so on. And so really, how I'm framing this is as a governance challenge. And this diagram was contributed to this research by Michael Zygum as part of our work at Block Science together. And so what this does is try to frame AI agents as really subject to decision-making authorities. So they're deployed in a specific context, not by no one, not by magic, but by different forums that represent different stakeholder groups. So they can make specific decisions that have effects on the outside world, but really there's stakeholders that are deploying them that can be the focus of questioning consequences and enforcement. And so what this does is starts to map the sort of prevalence of AI agents against the people also participating in a system, the purpose of a community or a system, and the broader environment. And those ideas come out of a piece which is available on Medium called What Constitutes a Constitution, which talks about constitutive infrastructure and this idea that the rules of a system are not just embedded in one place, but actually across it, which can include the technical infrastructure. In this case, the constitution of the LLM itself is part of the kind of constitution of that system within a broader context. And so starting to place AI accountability in context, this diagram was developed by Jacob Hackel at Block Science in conjunction with myself around looking at the composition of an actual agent in relation to a forum that deploys it, and starting to position some of those governance considerations, including internal monitoring, consequences and enforcement, as well as the constituting of an algorithm. And so we've been through this process at Block Science with our own internal knowledge management system, GPT, or KMS GPT for short. And it involved asking those questions and actually setting policies around data management, data access, who has access to the GPT agent, what are the ethical considerations in terms of what data it's trained on, how it's tuned, and so on, the underlying model we used, and so on. And so this diagram is kind of nested of the previous, and it starts to include some of the other forums. So not only the LLM in context of the forum that maybe develops or deploys it, but also the forums in which it may act. So starting to think about really those feedback loops between external forums and then the forum that has access to the internal or that kind of governance and constitution of the LLM itself. And so possible design directions. I should mention I'm a social scientist and ethnographer by training, which is a sort of subset of anthropology, which is very helpful for looking at the outcomes, especially the kind of human outcomes or social kind of consequences of technology in this context. To take those insights and then transform them means to start to look at the design questions, which is more where block science comes into the perspective. And so partly that governance design comes in at the constitutional level around shaping the objectives and constraints of an LLM itself. As mentioned, the constitutive infrastructure here. And then there's some other models that I'm exploring, such as the ethical regulator theorem by Ashby, which is about really aligning all regulation or all kind of rules and constituting below the purpose, which is another way of that people, purpose, and environment framing. And so based on this research so far, we start to surface some possible responses to some of those open questions that I've raised. So where does AI operate? Well, where an organization, an individual, or a community decides to have engineers build and deploy it. Who controls it? One forum through constituting the algorithm, monitoring, accountability, enforcement. What is the identity of an AI? It depends on the application, but needs to be considered. How can a forum question AI? Well, an internal forum controls the constitution, so an external forum can have that relationship of accountability, which is that interplay or that back and forth sort of process of inquiring as to how an outcome was reached, to bring sort of greater accountability there. And then consequences. So unless we're talking about sort of future iterations that aren't here yet, if it's possible to identify who has deployed an agent, then it's potentially possible that a provider could be punished in some way. I'm really interested to see or to speak to people if they've got ideas about how that space could develop in terms of what mechanisms or levers. We think about punishment often in kind of like legalistic terms, but it could also be economic or sort of technical mechanisms there, as well as, of course, social norms. And so the further research agenda that pertains to this idea about AI accountability and accountability in context of private governance more broadly, which is my postdoc research, is around human coordination in surfacing the preferences. So how does that initial process of constituting actually happen amongst the geographically distributed or diverse group of people to determine the policies in the first place and on an ongoing basis? How do you ensure local level governance, so subsidiarity, that people close to where an agent is operating are actually able to monitor and sort of respond to those outcomes? And then, as I mentioned in the previous slide as well, what are the regulatory forces at play in these contexts? Are they legal, or are they also technical, economic, or based more on social norms? So what's actually effective consequences, and how can they be enforced in these contexts for accountability where these operate? And that might even be, to sort of situate this or ground this a little bit more for the potential audiences listening, that could be accountability to your own community. So if you hook up, Autonomous, which is the example I'm using today, you want to know that your own community can then hold the community to the governance decisions made and actions taken, especially if they're automatically enabled or whatever based on that through smart contracts. And so, as promised, this comes with a call for both field sites for further research. So I'd love to get in touch with anyone that is interested in talking and potentially doing participating in some interviews and having me sort of dig around and observe your work in a little more detail to flesh out my understanding of this space and contribute research to it. But then also people that want to more deeply and more formally explore the governance processes and the actual mechanism design here. And that could include the mechanism of that interplay, that back and forth of questioning between forums, actors, agents, and so on, or more about the actual regulation that ensues from that process. So true to time, thank you so much. Thank you so much for having me as part of this mini conference, and I hope to hear from some engaged people.
Awesome, perfect. Hi, so my name is Levi. I come from LilyPad and Bacalhau, which is an open source distributed computing platform built at Protocol Labs. So Bacalhau is basically running any arbitrary Docker or WASM image anywhere from IoT devices all the way up to GPU servers. The point is to bring the compute to the data rather than the data to the compute. Sorry, the compute to the data, rather than the data to the compute. So if you have like a 5 petabyte or terabyte or whatever data set over there, you can send the compute to where it is and have it computed there and then get the result back. And LilyPad is the incentivization layer on top of this. And it's basically a permissionless, trustless, two-sided marketplace for compute. That's the simplest way to put it. So basically, in these environments, you basically, because they're trustless and permissionless, you have to have some kind of protocol for verifiable computation. So you basically need to know if I send this task to that node, how do I know that that node is giving me the result back correctly? And so there's a few ways of, verifiable computation is a very large field with a lot of research, associated research. We have, of course, cryptographic protocols like ZK, zero knowledge proofs. We have trusted execution environments and so on. Right now, we're focusing primarily on verification via replication or optimistic verification. So basically, you double check the work however often on some other node and compare the results. And then the question is, there's a lot of kind of game theoretic problems in that. So like, of course, how much collateral do you have to put up? How often do you check? How do you prevent the node that you check with from colluding with the other node? And so there's a kind of a rich problem space there that, impossible to cover in 10 minutes, but it's very, very interesting. And there are other kind of related questions also, like how do you actually price these computations? And then how do you schedule if you have like kind of more complicated tasks than just running one computation against one node and so So basically, the overall approach we're taking to this is we're taking some inspiration from the revelation principle, which is a central result in mechanism design. And so I want to be really clear, we're taking inspiration from it. We're not using the revelation principle. We're not dealing with social choice functions or anything like that. But basically, the idea is that we want to design autonomous agents that represent clients and compute nodes in this two-sided marketplace to maximize their utility, right? And so, utility maximization is a common assumption in game theory. We know that, in real life, we have these questions like, does utility even exist? Are we even capable of understanding what our utilities are? If they do exist, can we actually enact them rationally, and so on and so forth? But in two-sided marketplaces where you have kind of relatively restricted environment, you can actually say, yes, we want to maximize, I want to minimize my cost based on getting this result back from a particular period of time, or I'm a compute node, I want to get the most money I possibly can for computing this task. And so we basically want to design these autonomous agents to, to maximize utility, even if that includes cheating, right? So a compute node can say, I want this node to represent me and bring me in the most amount of revenue possible. And if that if that autonomous agent decides, the best way to pull in the maximum amount of revenue is actually to just give a false result to that node, we want to allow the autonomous agent to do that, basically. And then that's kind of the first kind of axiom of this approach. And the second axiom is, all other components of the game should drive the probability of that cheating happening to zero. So basically that, there's kind of a lot of different ways of going about this. There's like different types of commitment devices, different types of ways of putting up collateral. There's different ways of checking with consortiums rather than just checking against a particular node. And there's of course differences between if you're a client and you're sending the same task to a particular node over and over versus if you're just sending it out to the wild to any node that you can find. There's all these kind of different possibilities, and it's kind of this very, very interesting and complex environment. But this is the kind of the essence of it, right? We want to have these autonomous agents that are representing clients and compute nodes, and we basically want to be designing a global game such that the probability of any of dishonesty basically is driven down to zero. And so anti-cheating mechanisms are also kind of fundamentally related to pricing and collateral as well, because whether or not it's worth it for you to cheat is also dependent on how much collateral you have to lose if you get caught and how much you're getting paid to do a job. And these are kind of intimately related concepts as well. And naturally in a two-sided marketplace, things are very, very fluid, and you can have fluctuating prices that are a function of the supply and demand of the compute resources on the network. Depending on the time of day and the geolocation, right? So like computation, you can imagine computation being cheaper at like 4 a.m. In particular, or maybe even every part of the world than it is at 4 p.m. And that's also partly because electricity prices oftentimes are much higher at 4 p.m. Than 4 a.m. Especially in hot areas. So it's you basically want these autonomous agents then to actually be able to negotiate over the price, right? You want them to be able if you have 100 clients that have 100 tasks each, and then you have 1,000 potential compute nodes, there are many options of how to kind of combine them. This is kind of classic, two-sided marketplace, two-sided matching problem, and so on. And there's like mountains and mountains of research on this. And they have to be able to negotiate, over price, bandwidth, latency, the time to accomplish a task. There's like a very wide range of kind of aspects of the computation that these agents are going to want to be able to negotiate over in order to kind of derive the maximum utility for their respective humans, basically. And there's been, going back to especially in the 90s, there was tons and tons and tons of research on distributed AI, especially negotiating, overpricing, and scheduling. And it's really interesting in that, we had these kind of like multiple AI winters, and, this kind of research, maybe it was kind of used in industry here and there for like, scheduling in data centers, or for, maybe scheduling in kind of factories and so on and so forth. But it didn't really hit like, it didn't really hit the public conscience in terms of what it could do. We're living in a different world today, with ChatGPT, with Llama being open source, Stable Diffusion, Midjourney, etc. We're living in a fundamentally different world of capabilities, that and all of the prior research that kind of that was happening before these AI winters in the 80s and 90s and in the noughts. We now see that like we've kind of overcome that hump in terms of computational power available to actually kind of enact these ideas in real life. And it seems like that's going to be true for distributed computation as well. Distributed computation, it probably hit the public conscience most prominently with SETI at home in like the late 90s and early 2000s, and with BOINC and other kind of folding at home and other distributed computing platforms, but then it kind of fell to the wayside and so on and so forth. Yeah, and so we're living in a kind of fundamentally different world, and there's massive new opportunities for this. So one last point before I go to questions. So for complex compute tasks, this is kind of it's just to give you a flavor of how complex this can get, how interesting it can get. A client may need to negotiate with pools and coalitions of nodes, right? And that gets really complicated because setting aside the anti-cheating stuff, when you're negotiating with a bunch of nodes at the same time, I mean, do you have one central node that is orchestrating all those other nodes, or you're negotiating with all those other nodes at the same time? How do those other nodes check that within their coalition that the computations are being done correctly? You can, by the way, going back to the anti-cheating mechanisms point for a second, you can have prediction markets for is this node going, if it gets checked, is it going to be caught cheating and so on? But then again, you have to account for collusion problems and so on and so forth. So that's basically an overview of where autonomous agents can be used in these environments. And yes, I'm going to go to questions. Oh no, wait, sorry. I think the questions, Thomas, did you want to ask the questions?
Sure, yeah. So we have one question so far. This is from Richard, who's asks, have you tried to run an autonomous agent on a Bacchiao compute node yet?
No, but you're front running me a bit, because I kind of want to. So basically, I'm considering for my own purposes writing like a research agent. And like there's already like open source versions of this. I would probably just fork it and modify it a bit especially when you're talking about research papers. I mean, especially since we're building on top of IPFS and Filecoin, we have access to like massive amounts of storage, and so we can kind of take in massive data sets of scientific papers and so on and so forth and run computations over them. So I'm considering personally playing with that, but right now we're mostly focusing on actually building out the two-sided marketplace itself, as well as focusing on other kind of more interesting use cases like LoRa fine-tuning, Filecoin data onboarding. I think we just got STXL running recently as well. So we're kind of focusing on those kinds of use cases and building out the two-sided marketplace. The autonomous agent stuff is the goal is basically we need a robust two-sided marketplace first before it makes sense to really start exploring more in research terms, because there's mountains and like literally decades of research on this topic, but without the actual infrastructure to have these negotiations, then it's kind of just it will remain in this kind of research area rather than actually being implemented.
Cool, great answer. I have one that I thought of when you were at the beginning of your talk, you mentioned the idea of like utility. I'm very interested if maybe you could talk about defining and measuring utility, particularly how might you change the measurement of utility over time?
So I mean, in this context, utility would basically be, it depends on the context of what the node wants, because different nodes are going to want different kind of results. So your utility could just be a function of purely of price, minimize the price, but that might mean, for example, that your job gets run at 4 a.m. 3 days from now, and it takes 12 hours because it's running on a Raspberry Pi, and like, so you minimize your utility, or rather you maximize your utility by minimizing your cost. But if you start including other aspects of utility, like how quickly do you want the result, how much data is being produced, so like what's the cost of the data transfer going to be, up from coming from the other node, and so on and so forth. I'm interested, kind of taking this would be a step beyond what I've just described, but if you could describe what you want in terms of natural language, and then have an LLM translate what you want in terms of natural language into a scheduling algorithm, not even necessarily into an algorithm, but a set of constraints that this autonomous agent runs or tries to achieve in negotiation with all these other clients. That's kind of where I think it will probably end up. But we have to build modularly in order to get to that point.
Awesome. Yeah, can't wait for that. Okay, thank you very much, Levi. I'm going to bring up Emma now. Okay, so we have Emma Sharma joining us from Polyrap today. How are you, Emma?
I'm doing well. How are you doing?
Very good. Glad to have you with us.
All right, sounds good. Hi, everyone. Emma here. I'm product lead at Polyrap. Recently at Polyrap, we've been working on this product called PolyGPT, and I'm here to share a little bit about what PolyGPT is and what problem we are trying to solve. So let's dive in. For PolyGPT, basically it's an AI agent with on-demand capabilities. To elaborate, first let's go into what is the problem space we are dealing with. So currently the agent, like today, when you look at the agents like AutoGPT or Baby AGI, if you use any of those, the constraint that these agents have is they can only do the functionalities that they are pre-built with. So let's basically walk through an example, right? So let's say you're in AutoGPT and write a prompt of like, okay, give me 200 words summary, let's say on Vitalik, and then save it as a file. If you were to do this, first of all, you would first, to set up your AutoGPT, you're going to go and pre-install web scraper command, and then you're also going to go pre-install file system command, which let's call them functions, right? So you would have these functions pre-installed, then you'll go write this prompt in AutoGPT, and it's going to go scrape and give you the summary, write the file. So great, it does this for you. But now let's say as you did this and you read the summary and you saw what was going on and you got more curious and you're like, oh, actually, I'm curious, what is Vitalik actual wallet address? And like it's Vitalik ETH is his ENS, and then also like how much ETH it has. So what's going to happen at this point, AutoGPT kind of breaks for you, and you can get around it by doing manual stuff. Like you can manually go and first find what are the functions for ENS, what are the functions for ethers, and then go pre-install them. Or worst case, if they don't exist, then you have to go write those functions, be a developer, then go pre-install them. And then you're going to come back, start from scratch, and then you would potentially be able to go through this whole prompt. So it sounds kind of tedious. It's something which like you have to preemptively know which commands you're going to need and pre-install them. So to solve this problem, this is where we have PolyGPT coming in. And the main value prop we have is that that PolyGPT is able to learn new functions on demand. And what it really does is that you don't have to go pre-install commands. You basically are going to set up your PolyGPT. It will have commands installed, whatever the basic module that we have. But then apart from that, we also have this whole wrap library, which is dynamic on the back end, right? So you can contribute towards it, and we have the community that contributes towards it. So it's just like ever growing ecosystem. And just once that you have installed it, this PolyGPT now can always go reference that wrap library that we have and learn the functions on demand. As and when you put the prompt in, it'll be like, oh, okay, let me go check this library. Go check. There is a function which solves for you. It's going to come back to you and be like, hey, I know a function. Should I learn it? You'll be like, yeah, go ahead, learn it. And then it's going to continue that instead of you having to kind of halt and go and pre-install. So that's basically the whole part we have here. I wanted to quickly show you the demo of this exact example so you can see just on the screen how it comes through. So let's say you install PolyGPT, start your PolyGPT, and then we first start with that basic prompt, which I talked about in the beginning, to write a 200-word summary about a topic, and then save it into the file. So far, I think AutoGPT is also very good in doing this, and it would be fine. So this is where we are doing exactly same what AutoGPT would do. So it's thinking, it's going, basically doing the web scraping aspect at this moment. I'll just let you watch. Sweet. So it does that, and then it's asking you about the file system. Can it learn the file system function? So you say yes, sure. So now it's learning the file system function, which basically is going to enable it to save that summary to the file called vitalik.md. There you go. So it goes, it does that. Now it's writing that file in there, and then the assistant kind of just gives you the success message that it has done. And AutoGPT is also very easily able to do things up to this stage if you have pre-installed the commands. But now we give the second command here, as you can see, that is to go now look at the ENS of Vitalik and then give it the wallet name and the ETH. And even though this command, this ENS function was not available, it's asking you that, can I learn it? And when you say yes, it basically is learning it from the existing library that exists. And then after it learns, it goes, executes, and brings in the address name. And then right after that, it does similarly same thing. Also for Ether's wrap, as you can see right now, it's asking you if you can learn Ether's wrap. So you're going to go ahead and say yes. And it learned the Ether's wrap. And now it's going, checking the price, how many ETH does that given wallet address has, and then giving you the value out. So now you can see at the end, you have that Vitalik's wallet address is this, and then this is how many ETH it has. So that's how that's exactly how PolyGPT works. And as I mentioned briefly previously, it's like highly dependent on this wrap library that we have on the backend, which is basically a community ecosystem from PolyWrap. We are adding new wraps in it, maintaining it. We also have community based contribution towards it, so anyone can go, it's open source, so anyone can go add new wraps, add new functions into it, and it will be able to make PolyGPT, whoever is using PolyGPT, dynamically pull in those functions to learn. So yeah, that's my presentation. And then for call to action, if you all think this is super interesting or like curious about it, we have the code base and demo on GitHub. So click on the link, try out how it works, try other functions which might not be in there, pull it in. If you have any questions while you do so, ping us on Discord or follow us on Twitter. Thank you.
Awesome. Thank you for that. It's really cool. And I'm glad you're able to get a demo in. I love it when there's a demo. So we can take some questions, which, yeah, as I said before, I'll read them out so the people watching the replay will know what the question was as they hear the answer. I also have been able to use this cool feature where I put the question on screen, which I hadn't used before, but that worked quite well. So while we wait for some of those questions, I'm curious if maybe you could talk a little bit more about the community library of RAPs. I thought that was really cool. Like what's in there,
Yes.
like how do you incentivize people to contribute, those kind of things.
Yeah, so we are very early actually. This is proof of concept, and we are using polywrap technology as the fundamental, like the wraps that we use, which makes it super modular. So far we have ethers, ENS, as you saw, like the file system, HTTP, and web scraping. So like we have around 10-ish commands right now. We only started working on it 2 to 3 weeks back, so super fresh. But yeah, our idea is basically as we share with more folks, we want to continue adding more and more commands within that library.
Awesome. Cool. So we have some questions from our viewers. We have Oak asks, what have you used PolyGPT to do so far?
Yeah, so I think like, but as one of the examples I was mentioning here, but the whole concept for us is that we are actually building this another product called Unblock. We haven't launched it officially yet, but we are going to be able to use this on-demand learning functionality, basically, to be able to learn and go and do anything that you want. And the biggest, like, just think about like simple things, which we also tend to kind of practice or like do use cases around, is like, if you want to send out emails, right? Like right now, it would just be like, it can craft an email for you, but it's not going to like connect and send an email unless you go and pre-install the command. So we're just trying to do that, how you don't have to go pre-install commands every time you need something, versus you just go type what you need and then it finds it for you. So that's basically the main part.
Cool. Okay, so I have another one. This is from Richard, who asks, have you used AI agents to interact with some of your Web3 wrappers?
Yeah, we have used AutoGPT to interact with our Web3 wrappers. It kind of works, but I think, yeah, I think like it works fine. The main part that the gap, and I think that's how we figured this gap out, was when we were trying these AI agents, was that to use our wraps, we would have to go and pre-install those commands for the wraps to be available in a given agent. Yeah, but for PolyGPT, basically, you can also still use the wraps, but you don't have to pre-install anything. It can be just on demand.
Cool. Okay, we have another one. Is this or will this be distributed or decentralized?
Yes, great question. We are very early, but it is going to be completely open source. So everyone and anyone is welcome to try. It is currently open, so like feel free, go try it out. If you want to fork it, make your own version, feel free to do that.
Awesome. Okay, something I like to ask recently has been, what are you really excited about? And this could be about what you've talked about today, or maybe you could go a little bigger picture towards the theme or even larger.
I think like I'm actually very excited about this particular use case, because for me personally, it was a very big pain point that every time you need to use AI agents, it was like such a blocker and so time consuming that you start doing something and then in the middle of it, you're like, oh, I need this command. And not only you go install, you have to basically do all the steps from step one all over again and then get to that point. So I think this particular project could be very exciting from even the aspect of discovery, and then aspect of if you want to do long executions of an idea or theme that you're looking for, how to not get blocked and have to go and reinstall all of the things. Yeah.
Cool. Yeah, I love that answer. Anything we can do to make this stuff easier to use, where you don't have to break the flow, I think it's going to be really key to having, yeah, I mean, the focus of our event here is autonomous agent applications. And so we want to think about what are the end user applications. And if you have something, yeah, where you have to stop and completely start over again, one, it's frustrating, but it also is going to slow down innovation. People will get frustrated and they won't contribute, for example, to like your community repository things when they first experiment with it is too hard to use, or it's too frustrating, or just, yeah, it doesn't work. Okay, yeah, cool. Anything else you want to mention? So you already shared where we can follow you and these projects. Is there anything else you want to mention before I bring up our next speaker?
No, that's pretty much it. Yeah, I would definitely urge everyone to check it out. And we love feedback since we are so early stage. So as you use it, please share feedback.
Awesome. Okay, Emma, thank you very much. That was really cool.
Yep, thank you. Bye.
Cool. Okay, so I'm going to bring up our final speaker for today, Sam Green. After Sam, we'll have an open QA session, so please do stick around for that after his talk finishes. So let me get him up now. Hello, how's it going?
I'm doing great. How are you doing?
Awesome, really good. Glad to have you with us. Cool, and I see you've already got your slides set up here, so I will put those onto the layout.
Okay, thank you. Thanks for having me today, and hi, everyone. I'm Sam Green. I'm a co-founder and the head of research at Semiotic Labs, and today I'll be presenting on our work with using reinforcement learning for query pricing in the graph protocol. I'll first give an introduction to Semiotic Labs. I'll then cover automated price discovery, our automated price discovery work, and how we implemented and trained models for or agents for bidding in the graph. And then I will quickly show how our agents are working in production. Semiotic was founded in 2020 by AI and cryptography researchers. We've received funding from the National Science Foundation. We're in the US, the Graph Foundation, and Infinity Ventures. We're focused on applied research, and we are a core developer team of the Graph protocol, where we focus on AI and cryptography. And we are also the creators of Odos, which is a smart order router. Okay, so here's our scenario in the graph protocol. So at a high level, for those of you that don't know the graph, what we do in the graph is we index blockchain data, and we make it easy for people to query that blockchain data. And we're used primarily for dApp developers to build decentralized dApps. If you go, for example, if you go to Uniswap and you look at their price feed and look at where the data is coming from, that's all coming from the graph, and we're used by most other major protocols for their data for their dApps. What happens in the back end is that we basically it's a two-sided market where we have customers they want to get queries, they want to get data, and we have indexers who index the blockchain data and serve it to the customers. And so what happens is we have this marketplace, a query market. It happens on this thing called the gateway. And customers, what they do is they'll send the queries that they want, GraphQL queries, and their GRT, which is the token they use for payment for queries, to the marketplace. And then indexers get to see what particular queries are coming in, and they will place bids in order to fill the queries. They don't get to see the actual budgets of the customers. That's a key point here. And of course, then the indexers receive the queries and they receive the payments for when they get to fill those queries. We have this talk is about a tool that we have been building that we've deployed into production. It's called AutoAgora, and it does dynamic pricing based on the query volume received by an indexer. So we're using agent-based modeling. We used agent-based modeling during the development of AutoAgora. And if we look into the details of what's happening when we were doing development to build the models, we had a simulation environment that had a query distributor. It basically chose which agent got to fulfill or fill the query. And it also it has a traffic generator that simulates query volume. And then we have agents that can express bids in a domain-specific language called Agora. And that's why we call the system AutoAgora. Our agents are based on Gaussian bandits. These are a subtype of reinforcement learning. So they solve the exploration, exploitation problem. The bandits are very simple. They have two parameters, which they parameterize a Gaussian distribution. So this means basically these agents choose prices and they select prices from this distribution. And these are yeah, so this is what we use. So for example, here we have an agent that has sampled 0.8 for a price, and we see that it has a fairly tight distribution, which means that it's unlikely to select prices out of this area. And then we have another agent that is also interacting in the environment, and it's sampled a higher price. So some assumptions that we had for during training was that our query volume is parameterized by these two parameters. We have a query price that can be that will adjust dynamically, and we have query volume that will adjust dynamically. And so again, this is for generating. This is for development purposes, for training, or I'd say building the solution. And what this is doing is it's generating queries for the simulations for the agents to train against. And then if we look at what the goal of the agents the agent's goal is to maximize their revenue. So that's their objective, is to find prices that can win bids and fill the most queries and maximize the revenue. And on the other side, in the marketplace cares most about quality of service. They don't care about revenue maximization, or the marketplace doesn't care about revenue maximization. Okay, I'm going to give you one of our experiments that we did during development. We had a single agent placing a bid. The bid went into the marketplace. The marketplace, it was receiving simulated GraphQL queries and simulated budgets from a simulated indexer. And this is showing you some results from a trained agent that learned how to interact with that environment. So this experiment I'm showing you has a single agent. We've also done many experiments with multi-agent and multi-consumers. This has a single agent, single consumer. I'm going to show you a video in a moment, and I'd like to help you understand what that video is going to be showing. At the top, we will show a plot that visualizes the query volume, which is represented by this line, and a budget, which is represented by this line. So this line right here represents how much the consumer is willing to pay for their query. An important note is this amount is hidden from the indexers. So you can think of this as the indexers are trying to discover what the clearing price is in the marketplace. They don't know a priori. It's not given to them. And here, what you see with this dashed line is it's the initial policy, and that will stay fixed for the visualization. And the solid red line is the current policy. We then have the query volume served by the agent. We have this is going to be the total queries that are served by the market. This is the agent's revenue. You want to see it going up and to the right over time. And this is the aggregated revenue, the total, the aggregated agent revenue. So here is a video showing the agent learning. You can see that it is learning. It's exploring and adjusting to the right until it finds the clearing price. And then you can see its policy gets narrower and narrower, and until it can try to get just up to the price of what the budget is. We've moved this into production. So this is deployed. It's also open source. It's available to be used by all indexers. And here you can see that this is tracking it in production. We can see that the mean of the policy is going up. That means it's finding the price that can maximize its revenue. Its variance goes down. That means it's uncertainty about where its maximum price is. And here we can see that the rewards that it's getting over time goes up. So I appreciate you guys being here today. If you'd like to see a full version of this talk, we presented at DevCon in October. This QR code will link you to a YouTube video. If you'd like to reach out to me, you can email me at sam@semiotic.ai, and my Twitter is 0xsamgreen.
Cool, awesome, and right on time. It's 17:40. So, yeah, that means we have 5 minutes to take some questions, and we do have some already. So,
okay.
Yeah, Levi asks, did the mean of the distribution match the max price the customer was willing to pay in the end, or was it a bit lower to increase the probability of a match?
Oh yeah, good question. It's a little bit lower because the variance is never going to go to zero, and yeah, so during that simulation it goes a little bit lower. In practice, what is happening in a multi-agent? In practice, we have a multi-agent situation with the data sellers, with the indexers. And so what ends up happening in practice is you get these policies that are wider because there is basically the competition between the agents causes there to need to be, there just needs to be a wider distribution. So they don't get to maximize the revenue if they're, they don't get right up to that border if they're competing.
Cool. Okay, so there's another one. This is from Michelle. Michelle asks, in the past, we've been trying to do decentralized Uber or ride sharing, and one of the hardest things to solve was to calculate the price for a ride. Could you talk about how this could be used for this?
Yeah, so let's see. Michelle, is this so you could imagine like I mean, in general, I think these sorts of solutions, these bandit solutions, are very extremely popular for this sort of application. There is a lot of previous work in this domain, and I'd say in general they're a nice solution to try if you're trying to bid for something and you don't know what the price is, that it's going to clear, that's going to win the bid. And if the bid price is changing all of the time, like if the optimal price to bid is changing all the time, these are good solutions. If the price is changing, if it's jumping around like super erratically, this solution, I mean, it'll still work, but it becomes harder. If the price that you need to bid shifts gradually, given like, let's say, fluctuations in demand, then I think these are good approaches to try.
Interesting. Okay, I have another one for you. So another one from Levi. What challenges did you face when transitioning from agents trained in simulation to agents in production? Great question.
Yeah, that's a great question. So in production, of course, you have the simulation to reality gap, and that's what this question's about. Let's see. So in practice, it's difficult, or in simulation, it's difficult to capture the fluctuations in market demand. And so what ended up happening, I'll give you the most interesting lesson. What ended up happening is we deployed this on for a subgraph, which is basically like a little marketplace that ended up having no queries. And our agent didn't know that there's like nothing to be had at all. And so what happened is that the policy got so wide, the variance got so wide because it didn't know what to do. And so it became so wide that the policy basically exploded because it didn't know what the price to converge on, because there were no offers that were even available. So that was that was an interesting challenge.
All right. Okay. So it looks like that's the end of our text questions. Is there anything that you didn't get to mention? Maybe you could talk a little bit about how people could connect with you if they want to experiment with this stuff themselves or just learn more.
Yeah, I think Twitter is the best place, 0x Sam Green. And we have open source repos for this. And in general, I'm interested in other applications of using RL for bidding agents in Web3 in particular. So if you're working on anything similar and you just want to chat about these topics, I'd be happy to chat.
Awesome. Yeah, I think there definitely will be at least a few of us who very much fit that description. Okay, so we have about 15 minutes left, so we've saved the last portion of this for an open discussion. So I'm going to bring up some of our previous speakers right now, and we'll use this session here to kind of let me. And by the way, speakers, let me know if you'd like to be removed, or you can just leave and you'll come down. But we want to use this session to kind of talk about, now that you've heard each other's presentations, what thoughts did you have? And I'd also like to bring back a question that we talked about in our first one of these sessions, which was about standards, where we focused on ways to think about interoperability. So I'd love it if maybe we can all think about that, and based on what you've heard from each other's presentations, maybe we can think about how we can build these things so they work better together. But I'll let.
I mean, I can think of a bunch of ways. I mean, presentations from Sam, Emma, and Lewis probably all apply in to some extent or another in what we're doing at the LeapPad. So like, for example, for Lewis's presentation, I'm the only researcher, so I'll say but I've definitely been considering exploring prediction markets for it's kind of like there's this really interesting protocol called TrueBit, which some of you may have heard of, which was kind of for verifiable computation, and it had some limitations and so on, but they did have this mechanism in there using taxes and jackpots. So like everybody gets taxed a bit and it puts into a jackpot, and if you find like somebody cheated, then you get the jackpot, and that's how but then you force errors into the thing, so people will definitely find errors, and that's how you incentivize checking and so on and so forth. There's a way you can incentivize checking. You can use taxes as well, and like kind of modify a bit the concept of participatory budgeting, which is like you decide where your taxes go, and so you could get taxed, but you could decide where to in a prediction market, like who do you want to bet on that is going to be honest whenever they get checked and so on. You could have kind of staking and slashing in that regard. Like PolyGPT, I mean, you could, like I was saying with the LLM stuff, you could totally change kind of natural language and so on into a JSON format and stuff for like running scheduling and so on, scheduling algorithms. And then that's what Sam described is and especially with obviously the pricing model, like we're obviously working on pricing models as well. And so, but especially I really wanted to ask about like if you considered because it seemed like it was only like a one-time kind of exchange, as in like somebody bid, and correct me if I'm wrong, but it seemed like somebody bid, and then if the bid was lower than the ask, then there was no match at all. But it seemed like there was no negotiation in that. So like, is it possible to introduce negotiation with autonomous agents and so on and so forth? It's kind of something that I was thinking about. But yeah, I think there's definitely a lot of kind of intermixing.
Sorry, Levi, were you asking a question? Were you asking that to me?
I was just like, I mean, Thomas asked what overlap is there, and I'm like, I see tons of overlap.
Yeah, there are. I agree. I mean, imagine, imagine like on the. I think there are a lot of marketplaces, of course, in crypto, and I wonder if we should work on standardization for, at least for interfaces. Every marketplace will probably have like a not proprietary, but a distinct implementation. But I wonder if we could work on standardization for abstracting the implementation for agents to participate in these various marketplaces, and that'll make it easier for people to, extend work from one, project to another, to collaborate.
Yeah, and actually, I just wanted to add to like enable that abstraction easier. What PolyGPT is built on is the polywrap wraps, which I mentioned briefly. But the concept of wraps is basically how we can abstract the functionality from its backend or architectural part and standardization. And we're basically building these like blocks where the interface is going to be same regardless of which protocol you're interacting with. But inside, the logic can keep changing, and that's totally fine, and no one needs to worry about it. So that would be quite interesting, actually, Sam. Like we could connect and talk more about it, of building wraps for your marketplace standardization.
Yeah, that would be great.
Cool. So
I have one other idea that I wanted to throw out there. And Emma, your presentation reminded me of this. So, I wonder if it would be interesting imagine, back in the day, there used to be this thing called like robots.txt that people who are running websites would include in their backends for search engines to understand about like more about the site. I'm not sure all what went into the robots.txt, but I think it helped it understand like the site architecture and stuff. Imagine if we had something similar for LLMs. Imagine like if every GitHub project had something that was specifically for LLMs to consume, for LLMs to understand how to work with that GitHub project. And that way, if you were building like LLM systems that wanted to like use the software in those GitHub projects, it could go to the repos and have like a file that was just for the LLMs to read. So it quickly understood like, hey, this is what this project is. This is how you build it. Here are the interfaces, and here's how you use it. Really customize for LLM consumption. And that way, if you're building these sort of like, systems building systems, it would be easier for the LLM to figure out how to build stuff.
Cool. So I'm going to ask Sandeep's question from earlier. The question was originally for Oak and related to what he was talking about, but I think all of you maybe would have an interesting take on it. So I'll have him answer it first, and then if you want to riff on it, please do. So Sandeep's question was, what are the top risks you see for a power to the people version of decentralization as a response to an institutional empire? Yeah, I think it's kind of what we were talking about at the beginning of this idea of the centralization, consolidation of power in the hands of Web 2 companies and government structures versus this Web 3 decentralized model where ideally we would have people owning that value. So yeah, Oak, if you want to.
Yeah, it's a good question. I think basically that my bias would be towards putting as much power into to the edges as possible and towards individuals and smaller organizations, because I think we're so far at the other extreme right now that it's to worry about the opposite is I don't think we'll get too far in worrying about the opposite. I mean, I think we have a very unique capability, being at the intersection of AI and crypto, to put AIs, to put autonomous agents into the control and ownership of individuals and smaller organizations. And I think that at this point that's only good things relative to the current situation that we have today are going to come out of that. But I'm certainly curious to hear if any of my other co-panelists here think there are severe risks. I'm very happy to hear them.
Yeah, and I think another comment we have expands on a similar idea, asking about a take on personal agents giving disproportional digital empowerment to those who are leveraging them over those who are not tech proficient.
Well, I think the interesting thing there is that, and we didn't get to go into this too much today, but I think most people's presentations did touch on it, is that the level of the sort of the abstraction that autonomous agents provide, once they're working properly, is such that even the least technical people should be able to get an enormous amount of value out of them. And I think in actual fact, it could be a real leveler across across individuals using technology. I mean, obviously today, it's, I think, you know, particularly Emma was pointing out with tools like AutoGPT, it's like still an extremely kind of technical experience. You have to be quite technically proficient to get anything very much at all out of autonomous agents. But certainly the goal, I think, that everybody really should be pointing towards is to you know, abstract as much of that away as possible, such that it's incredibly easy and simple, and that then the majority of people can really get much more out of it. Sorry, Levi, you were coming in. Over to you.
I was going to say pretty much the same thing you said. That it's a certainly in terms of the tech proficiency, I think it's a leveler. I mean, a lot of for example, we could just take a look at the you know, like, are there going to be programmers in 5 years? That whole, you know, kind of scary question, which is like, well, the implication is that, you know, coding is going to be so accessible to so many people that you know, the nature of, you know, the job won't exist. I mean, I don't think that's going to be the case, but like, you know, that's kind of the implication behind that fear. And so I'm not so concerned about the tech proficiency aspect of it. I am a bit concerned, actually, though, about the kind of potentially like runaway AI scenario. That does concern me a bit more. What I will say is that I remember having a lot of like serious conversations about this in during the in Paris, you know, with a lot of like kind of like the hackathon and so on and so forth about these problems. What the alternative is to regulation, right? I mean, just kind of, and then we know where that goes. I mean, what it means is that a bunch of, you know, centralized players kind of determine the future of AI, and which is probably very unlikely to be successful anyways, just because, you know, all of this stuff is going to the open source model. What was that, like that famous memo from Google, like OpenAI has no moat and neither do we. So it's very likely, I think, that open source models are going to win out. And then if they are going to win out, the question is, you know, if people start trying to do bad things with them, I think the inevitable result is that like good people are going to try to counter that and do good things with them. We, you know, so I think that when we enable people to, we empower people and give them the tools to be able to do what they want with this, that's probably the kind of, that's kind of like almost kind of like the collective Nash equilibrium of the, and maybe Nash equilibrium that's not always the best equilibrium. Maybe we can find better equilibrium than the Nash equilibrium, but worst case scenario, we give everybody their own kind of personal AI agents and let them modify them and try to do, you know, come up with the best outcomes that they can, because the alternative is, well, it becomes only some people are able to do it. And well, that's kind of, we know where that might lead. That I think that's probably a lot worse.
I think I'll give a less rosy response. I believe that we're entering this is a new technology which requires, like, when printing became you know, widespread, people either had to learn to read or they were illiterate. Similarly, people are going to need to either learn how to work with agents or they won't be able to. And in my opinion, everybody will need, I think that everybody will need to improve three things. One, their communications abilities in general, going deeper in whatever their level of expertise is, and understanding how to build complex systems. And with those things, communication, expertise, and knowledge of complex systems, and with those skills, they'll be able to orchestrate the tools that are going to be emerging.
It's this weird disconnect between, on the one hand side, these LLMs are usable by like people who haven't really been able to use any like more sophisticated technology before. So I'm seeing like my parents are using it, right? Maybe they have not been the earliest adopters of other technologies so far, right? But then on the like what so I feel like there we're good, right? And in a way that sort of that's a level playing field. But then I think the other I think the where my fear would come in would be the cost of, or kind of if you have a marginally better LLM, either that has better training or because you have more compute because you can afford it, or because you know how to run it on your home setup. So I feel like that's going to be the disconnect. Like everyone is going to use an LLM, but then some people might be able to pay the ChatGPT Premium Plus subscription, which is like 10 times as much, and then they're just like only marginally better, but that's enough to be like more intelligent than everyone else, kind of. So to me, that's interesting thing is on the one side, like democratizing technology, everyone can use it, but then on the other side, like the small differences become more relevant, and yeah.
Cool. Well, I love
disappear.
that. I love that slightly optimistic note, and I think that's a great place to end it. I know we have more questions, but this is the amount of time that we've allotted today. I want to thank all of our panelists for sharing their time and expertise and for joining the open discussion. I think we had some really great presentations and some great discussion. So thank you all very much for joining us. Thank you to all of our attendees. There will be a replay of this available over the coming weeks. We'll be releasing some content, the individual talks and the entire recording. So please follow Valory AG on Twitter if you want to be the first to see those. And thank you very much, all of you, for your time and attention.
Thank you.
Thank you.
Thanks, everyone.
Thanks.
Bye.
Bye.
Bye.